Good morning, everyone. By a show of hands, who's ever been in a traffic accident or in a fire? Who's ever been in any emergency situation or knows somebody who has been? Hey, that guy is feeling it. Consequently, who has tried to call 999? They didn't answer the phone. So you're saying it just doesn't go through. Anybody with a positive experience? Yeah, so I don't think anybody who lives in Kenya is shocked by that. So 57% of the world doesn't have a functional 911 system. And by 911 system, I don't mean we don't have ambulances. We have ambulances, we have fire trucks. If you go to Nairobi right now, you'll see 100 AAR ambulances. Hospitals have their ambulances. But we lack a functional central system for emergency response. To make matters worse, around 95% of Africa doesn't have a functional 911 system. So this is a very simple map of, this was visualized around 2017. So optimistically, things have improved, but not by a lot. So you'll see pretty much there's nothing. And because of this, around 3,000 plus lives are lost every year in Kenya alone due to road traffic accidents. And if you know anything about medicine, and also it's kind of obvious, catering to a traumatic injury in the fastest way possible is the best way to save a life. So there's a concept called the golden hour. It's a very vague idea that you need to react and to cater to a traumatic injury in around 1 hour to save a life. It's kind of a loose description, but 90%, generously, around 90% of these lives would have been saved if we had a working emergency response. So my name is Kelvin. As Alfred said, I work as a data analyst for FLAIR Emergency Response. So what FLAIR Emergency Response is, I like to call it a 999 that works. So what we've done is that we have ambulances in the country, we have fire trucks in the country. So we bring together all these providers and we provide you one hotline that you can call and get emergency response of any kind. So you want an ambulance, you can call a phone number. You want a security vehicle, you can call just one phone number. On top of that, we also provide access via an SOS API. So if you've used Bolt or if you've used Swivel, the buses, on your app as a passenger, there's an SOS button that you can press at any time of the day, whatever conditions of the day. You can press that button and we immediately respond to your case no matter where you are. So on our platform, at the moment, we are currently tracking over 100 vehicles. So this is ambulances, fire trucks, tow trucks, water bowsers, security vehicles. And on top of the 100 that we track live, we have a database of more than 500 that we know their approximate location. So these are the partners that we don't have active tracking, but we do know where they are, the services they provide, the capabilities they have. Our platform also works offline. So on the very rare cases that our dispatch center lacks an internet connection, our platform is also working. And on top of just having access to vehicles and responding at any time, we have a huge database of facilities in the country that can cater to different traumatic needs. So we know facilities that are well versed with treating, for example, spinal injuries, treating just normal wounds, and so on and so forth. So that's basically what FLAIR Emergency Response is. It's a 999 that works. So next time you're in an emergency, don't even bother calling 999. We should totally improve it, but at the moment it doesn't work. So just call us. So as a business, what we do is we provide we provide a package similar to an insurance package. So you sign up for a membership for around $2,400 a year, and you have access to all these services. So you can go to rescue.co and you can sign up. It's automated. It's pretty quick. Or you can also call the phone number on the banner if you have any questions. So since we've been around from late 2017, around the time after the elections were done and there were some election skirmishes, we've been able to reduce the response time by around 73%. So the response time is the time it takes between an emergency happening and an emergency vehicle reaching the scene. So before, it will take around 60 minutes for a vehicle to respond to your case, but now it takes us around 16 minutes. You'll see that this is still not the best, but we've reduced it by around 73%. The time it takes to locate a vehicle, before FLAIR it was around 45 minutes. So this is literally the time it takes a dispatch center to find a vehicle closest to you to come and respond to you. At the moment, you're doing it at 4 minutes, and at times we do it even in around 2 minutes, which is actually insane if you think about it. Then so far, we've responded to more than 3,000 cases and successfully taken people to hospitals or given people treatment on the scene. So all in all, we've been able to do a lot, but like you'll see, there's still quite a long way to go. So let's talk about traffic accidents, which is very close to what we are doing today. So around 2 weeks ago, there was a report by NTSA that was showing the number of casualties, the number of deaths due to traffic accidents in 2019 versus 2020 up to September 30th. And if we just take one of the metrics here, for example, the number of motorcyclist deaths. So in 2019, there was around 534. In 2020 so far, there's about been 774 deaths. Billion passengers, that's passengers on motorcycles, there's around 252 last year and around 300 this year. So in total, 2020 so far has more deaths as compared to the entire of 2019. And at this rate, we'll have a huge increase by the end of the year. Between October 2nd and October 4th, there was 60 deaths. That's 2 days. That's about 30 deaths a year. Those are very unnecessary deaths that can be saved if we just had emergency response that works. And just as a PSA, please wear your helmet all the time on a motorbike. Just wear it. It might not be the cleanest, but please just wear your helmet. These are very unnecessary deaths that a helmet will do a lot for. So these are some statistics that were done around 2017 about the kind of response that happens towards RTAs, road traffic accidents. So 16% of people injured in an RTA are treated on scene. And by treated, I mean just basic first aid. So these are people without very serious injuries, or they can take themselves to hospital. Around 76% were evacuated by well-wishers. So this is literally on the road. People just put you in their car and they take you to hospital. And unfortunately, about 1.4% were evacuated by ambulance. The remaining small percentage are evacuated by police vehicles. So this might look like a good metric, 76% being evacuated by well-wishers, but whenever you're whenever you're seriously injured, you're better off waiting for an ambulance to come than getting into the vehicle of an untrained professional to take you to a hospital. The reason being, for example, you usually, let me give you an example of the 1998 bomb blast. So during that time, Kenya didn't have trained EMTs. Hospitals just had ambulances and just people who drive the ambulance. So what happened during that time, during the actual bomb blast, ambulances would come and just park next to the rubble. Then people would literally just pull out people from the rubble and literally throw them into the ambulance. So we had so many deaths that happened because, yes, people are being transported to hospitals, but the way it was being done was just a mess. And actually, as a result of that, EMT training, or EMT stands for Emergency Medical Technician. EMT training actually started in Kenya because the medical community realized that we kind of have resources, but we lack training and we lack like a good way of doing things. So that ties back into evacuation by well wishers. It comes from a good place, but it's never a good idea. So yeah, also to you, if you find somebody maybe trapped in a vehicle or seriously wounded, call an ambulance first before you decide to throw them in your car and take them to the hospital. So as flare, I don't know how well you can see this map, but as flare, these are cases that we've responded to over the last, over 2020. These are very simple heat map of where they are located. So you'll see most of our cases are around, what's the term? Nairobi metropolitan area. This is kind of in line with where we mostly operate. So there is a bunch in Mombasa, in Kisumu, in the Western region. And in the last 30 days alone, we've responded to about 100 cases, which shows you that it's quite a mess happening in this country. So this is just a simple chart of the metrics that we are currently hitting and where we'd like to go, basically the world standard. So at the moment, we are locating an ambulance in about 3 minutes, and the world standard is about 1.5 minutes. So we'd like to shave that by around half. The response time, the time it takes the vehicle to get to the scene, is about 13 minutes. And the world standard is around 8 minutes. So we shave about 5 minutes. So the total time to care, that's the time it takes between the accident happening and you getting to hospital is about 63 minutes. And the world standard is a golden hour, 59 minutes. So as you're thinking about today's problem, think about, these are actually our main metrics. Think about what you're trying to do. How can it improve this? How can we get to this in the best way possible? So WHO has came out with a report in 2010 that identified 5 pillars of road safety management, or rather better to look at it is just reducing road traffic accidents. So there's road safety management. These basically are more infrastructure and policies. There's safer vehicles. This is mostly about policy and regulation. Then there's safer road users. So please use footbridges, cross at zebra crossings, the usual. There's safer driving environments. This is about infrastructure. So these 4 pillars 1, 2, 3, and 5, from the perspective of FLAIR and most people who don't work in the government, this is mostly out of our control. Well, apart from the safer road users. These 3 are mostly out of our control. It's mostly dependent on the kind of leadership we put into place, blah, blah. But pillar number 4 is something that we can do to fix it. So as FLAIR, what we do, the role that we play here is we provide a coordinated system, like I said, 1 phone number to get all kinds of response over the country. And we leverage tech and people to achieve this. So for example, for this hackathon today, the solutions that you're coming up fall into this section of, actually falls into both leveraging tech and people. So how can we use machine learning, or how can you use a very clever solution that you'll come up with to reduce how long it's taking us to respond to cases, for example. And so let me just show you a very simple chart of how emergency response happens. So you get into an accident or somebody gets into an accident. So you call FLAIR or you press an emergency SOS button. Then it comes into a dispatch. Dispatch triages the case. You explain it's an accident at this place, blah, blah. We can also access your location via your phone. Of course, you give permission. Then our dispatch center finds the closest ambulance. Then our dispatch center automatically routes the ambulance to your scene using just routing algorithms. Then when the ambulance gets to the location, they usually provide medical intervention. If it's not a very serious case, they will treat you on scene. If it's a serious case, they will then get back to dispatch and ask, this person has this kind is in this situation. Maybe they have broken bones. Maybe they have, I don't know, they have like some serious issues. So which is the best hospital to take them to? So our dispatch then finds the closest and most suitable hospital for the condition. Then they route the ambulance to that hospital. Then when the ambulance gets to that hospital, the patient is taken into the hospital and then they get care. So again, these three sections are not very much in our control. For example, about patient getting care, you find that public hospitals are not as efficient. Private hospitals, there's a whole issue of finances. So we're trying to do something about it, but it's currently not so much in our power to fix it. But these 3 points, the point where we find an ambulance, the point where we route the ambulance to the scene, and the point where we route the ambulance to the hospital. These are 3 points in the process where we can do something about it, or rather we can try and make it better. And this is now where you come in. So this is a screen grab of what the dispatch system looks like. So you'll see, I hope you seeing, so you'll see there's like white vehicles, blue vehicles, and red vehicles. These are ambulances located around, this is the CBD, I believe, around the CBD. Then we have several locations with cases. So these are like 3 cases here. Then there's another case here. So these are people who've contacted us with a certain issue. And so we display them on the platform so that, yeah, it's basically a visual representation of what's happening. So the way we do it at the moment is most of our partners have their area of operation. So you find, let's say it's a hospital ambulance will be located at its hospital. So maybe Nairobi Hospital, the ambulance is inside the hospital. Some private ambulance companies do like intuitively know where most cases are, but it's not 100% data-driven. We are working towards it, but at the moment it's not 100% data-driven. So this map basically shows where ambulances usually are located. So two ways to look at today's problem. So you see there's 3 ambulances here. These are 3 distinct ambulances. So the question becomes, should these 3 ambulances be redistributed to other locations, or should they actually just remain there because we are expecting a bunch of cases there? And there's this cluster of cases here. How can we make sure there's always an ambulance close to the cases or close to each case? And is it actually okay just the way it is? So as you're looking at today's problem, you can also use this as a visual guide of what we are trying to achieve. So maybe one of the ambulances should have probably been here to reduce the time it takes. Another thing to consider is, does it matter whether it's day or night? Does it matter the weather? And so on and so forth. So, one quick thing. So here about finding an ambulance, there's 2 parts to it. There is where the ambulance is located, and and the capabilities of the ambulance. So I don't think you have that data today, but another thing to consider would be, should we have multiple ambulances with the same kind of capabilities in the same area, or should we spread them out? Basically, there's a lot of things to consider, but specifically for today, just a quick overview of what the data you have and some ways you can approach it. You're going to get a deeper insight into it. But so you have road traffic accidents that occurred in 2018 and 2019. So it's just the time it occurred and the location, the lat long. Then you have daily weather data about literally the day. Then you have characteristics about road segments. So are there crosswalks? Do people cross the road wherever they like? Do people walk on the road? There is a lot of SaaS thanks to Uber for that. So with all this information, some simple questions to ask is, does the time of the day affect the number of RTAs we expect? Does the weather have any effect? Do places with zebra crossings have more or less RTAs? You might think it's less, but maybe it's more. So as you're approaching this problem, don't look at it as just a normal ML problem to just throw an algorithm at it and see which brings out the best score. Think about it as, if we actually to go ahead and implement your solution, how well would it work on the ground? Would it turn out to be over-engineered and not really working on the ground? Would it turn out to just be built to get a very high score on Zindi but not really usable on the ground? Because the solutions that actually win, we're going to try and implement them. So as you're working on it, as much as that there's the prizes, also think about the final implementation. Is it actually going to help save lives? So yeah, that's it. Thank you.